determine if a relation represents a linear function? Think about this question during the lesson. An auto assembly factory needs to purchase new welding robots. The factory manager has information on 2 different models of welding robots. Can he use a linear function to represent the welding rate of each robot? Notice that the welding rates are shown differently for each model. One model uses a table of data, while the other uses points on a line. How do the welding rates for the 2 robots compare? Determine whether the graph represents a linear function. The graph is a straight line, so it represents a linear function. The slope represents a constant rate of change of 11 2/10. All linear functions have a constant rate of change. The welding rate of model GNX007 is constant, so the function is linear. What does the constant rate of change mean for this context?
Select your answer.
Determine whether the table represents a linear function. Use values from the table to find the rate of change. The welding rates are not equivalent. When you find a rate that is different than the other rates, you can stop calculating rates. The welding rate of model T1000 is not constant, so the function is not linear. The welding rate of a third robot is represented by the equation 10 equals 10 8/10 times W, where T represents the time in minutes and W represents the number of welding tasks. Does the equation represent a linear function?
Yes, the equation represents a linear function. It provides the slope rate of change of 10 8/10.
Determine if the relation represents a linear function. Part A. The relationship between the side length and perimeter of a square.
The side lengths are represented here and the perimeter is represented here. And to find each input value has a unique output value, so the relationship is a function. The table represents a constant rate of change. The number of how they increase on both sides is the same, so they're all increasing by 1 here, and they're all increasing by 4 on this side. So the function represented by the table is linear.
Determine if the relation represents a linear function. Part B. The relationship between the side length and area.
Because each x value corresponds to exactly 1 y value, the graph represents a function. The graph is not a straight line, so it is a non-linear function. It has to be straight for it to be linear.
Identify the domain and range of the relation represented by each graph. Determine whether each graph represents a function.
Let's look at the first graph. Start here and it goes like that. The domain is x is less than -1. You have that open circle, so it does not include -1. That's why it's an open circle on the -1. And so x's domain, or the values of x, are all less than 1, which would be any of the points. The range is y is greater than 0. the y has to be greater than 0, does not equal 0. So the y value will be any of the numbers greater. So this graph represents a function because each x value corresponds to exactly one value. It's a straight line. This graph here is definitely not a straight line. The domain here shows x. It's a closed circle, so x is greater than or equal to -4. So you see how the line kind of curves, so it has to be, x's value has to be greater than 4, so it'll be numbers going this direction. And the range is greater than or equal to 1. So on the y, our 1 is here, and then it's greater. All the points will be going greater than that. So the graph does not represent a function because each x value does not correspond to exactly one y value. For example, the x value -2 corresponds to 2 y values, which is 1, and it also corresponds with the 5. So that is why it will not be a function.
The function v equals s cubed relates the side length of a cube to its volume. Is this function a linear function? Use a graph to justify your response.
So I started to create a table. I'm following these steps from the example number 2 where they had the table. So I labeled this first column side length. I couldn't label it up here, so I put it here. So side length, and then the second column is for the volume. So if my side length is 0, my volume is 0. If my side length is 1, if I were to put 1 in this formula, 1 to the third power would still be 1. And then if I do 2 in this equation, 2 to the third power would be 8. And then if I did 3 in this equation, 3 to the third power would be 27. And if I'm going to go one more time, 4 to the third power is 64. Okay, so that's not, I mean, it's gone to a point where it's, let's see, I zoomed out a little bit so you can see some of the points if I zoom out even more. Okay, or zoom. So here with the zooming out, me by creating this table allowed the points to be plotted on the graph. Now, if we look at this graph, the first thing we notice is it's not a straight line. So the question, is this function a linear function? The answer would be no. The line is not straight, which makes it linear. This would be a non-linear function.